Hi, it's Mr. Kane here again, and we're going to look at today about how to set up a fair test. We're looking at the scientific method for when you're going to be doing an experiment in class or at home somewhere. So how do we make it fair, and some of the terms that we're using. So we'll start with the aim. You have a target, a goal, something you want to find out. So every experiment, what are you actually aiming to do? What do you want to find out? This is like your title. You're investigating, I don't know, what makes a cake sweeter? Does the amount of sugar in the cake, changing that, does it make it taste sweeter or not? So we can write up an investigative title about that. I've already sort of come up with a bit of a hypothesis. Have a look at that. So it's a fancy word that means what you think's going to happen. I've sort of mentioned it with the cake idea that does changing the amount of sugar make the cake taste sweeter? Well, I think it will do. I think more sugar will make it taste sweeter. So it's an educated guess into what's going to happen. You've got to be able to test it. So the amount of sugar. So somehow I've got to think of a way how I can actually test that in a cake. And it doesn't matter if you get it wrong. It's what you think's going to happen, and if you're wrong, well, that's all learning. I mean, your experiments prove something already. Even if what you thought was going to happen didn't, your experiment has shown something. And sometimes you come up with a hypothesis first. Like the little lad in the cartoon, Kelvin, he's got this hypothesis and he's thinking it's going to come out of his ears, and he's actually going to go about and test it. So he's come up with this experiment after he's had his hypothesis. So sometimes they arrive together. Next, with the science experiment, we're going to come up with the method. So it's all the instructions that explain how you're going to go about doing it. You have to write them all down in a big long list, step-by-step instructions. So I tell my students that I could take their method and I could give it to someone else in a different class, might not even be a science class, and they could follow their instructions and they wouldn't need to ask any questions, and they could do exactly the same experiment. If the other person that's following your method has got to stop and ask you to explain or clarify something, then you need to fix your method. Your method should be able to be followed by anyone without them having to ask you anything. That's a good method. The equipment, yes, all the stuff we're going to need. So if I'm doing my cake experiment, I might not need all that stuff, but I'll need other stuff. So whatever you need to carry out your experiment, that's the equipment you need. And then add that into your method. So if people are doing your experiment again, they know what to collect, what they're going to have to use. Then we come to the variables. This is sort of the key part of your experiment. Okay, so we're going to be changing something and it will change something else. So we're going to be kind of careful how we go about doing that. So we're looking at the independent variable here. So it's the one thing we're changing. Now that's the important thing. That's the one thing we're going to change. So with my cake baking idea, the amount of sugar in the cake is the only thing I'm going to be changing. Everything else I'll be keeping the same. Now, all the other ingredients, the amounts, the times in the oven, the temperatures, everything else will be kept the same. Only the sugar amount will be changing. That is our independent variable. We've got this cause and effect thing. So I'm going to be manipulating the amount of sugar, and I'm going to be measuring the sweetness of the cake at the end of it. I think I'm going to be eating a lot of cake, but that's our independent variable, the one thing we are changing, and we've only got to have one. Like I could change the sweetness of the cake by changing the amount of icing on the top, but if I wouldn't know what was making the cake sweeter, was it the icing or was it the sugar in the cake? So I've got to limit it to one thing. That way I know that's the one thing that's made the change. So what's next? The dependent variable. Okay, that diagram before mentioned it. So this is what our results depend upon. There's some equipment. Yes, this is probably the thing I'm going to measure. So maybe it's temperature you're measuring, size, distance, weight, something's changing, you're measuring it. With the cake baking idea, I'm going to be measuring sweetness in the cake. How much sugar's in there. Might be a taste, I've got to make sure that's testable though. Maybe I'm doing some other chemical test, looking at how much sugars are in something. Maybe I could use one of the tests they use for wine to try that out, or the Benedict solution test, something. We'll have to look at that later on. Okay, these comes the important variables as well, the controlled variables. So we've had the independent, or things I'm changing, the dependent, what I'm measuring. Now, these are control ones, all the things I'm keeping the same. I have mentioned these before, so like I'm changing the amount of sugar in my cake baking idea, but I'm using the same oven, the same temperatures, the same utensils, the same other ingredients, the same amounts. I'm keeping everything else the same. Cause and effect again. I want the other factors out of the picture so that the one thing I am changing is the cause and I can measure the outcome. I'm not measuring something from something else, some other ones. Results. Okay, this is the information I'm going to be collecting at the end of it. So it might need process. Sometimes you collect stuff, you're measuring things, multiple things, and you want to average something, and you're going to put it in a big data table. Or I like graphs. A data table is this big whole bunch of numbers and it looks kind of confusing. You put that into a graph and you've got a picture of what's going on. Makes it a lot easier to understand. But the results is the information that you've got, your measurements that you've made, your dependent variable results. Okay, discussion. This turns the data, the graph, the data table, the numbers you've collected into some words. So we're sort of thinking about it so we can explain to somebody what our results are, what they actually are telling us. That's also tied into our conclusion. So what our results actually mean. We can discuss things, okay, the data tells us this. What does this actually mean? So all the ideas come together. So my sugar in the cake idea, the amount of sugar makes the cake taste sweeter. What is the science behind that? We can talk about the glucose being tasted by the glucose sensors, sweetness sensors on the tongue, and what's happening inside me of blood sugar levels and so on. We're getting into the actual science of it, science terms and things. And here's something that's key. We've got to link it back to our original hypothesis. Was I correct or was I wrong with the amount of sugar making the cake taste sweeter? Was I right or wrong? Doesn't matter which way you are, but we now can answer that question. I think with the cake one I already know the answer, but I'm looking forward to testing a few. Okay, the evaluation is a final wind up, and thumbs up, thumbs down. So we're going to review what went on. It's always good to review things so you can look back and go, okay, I could do this better or that better or change some things. So what went wrong? What went right? What went wrong? Checking the accuracy of things. How would I making my measurements all accurate and keeping things the same? Validity. We often look at doing repeats of an experiment. We'll repeat it several times to make sure our results are accurate and valid. We can get some averages. With the cake idea, I could be baking a lot of cakes here, I think. Sometimes we made changes during the experiment. Here we explain why we made changes. You've added things into your method, things you forgot at the start, bits of equipment and stuff that you forgot about in your initial sort of planning it out. You added it in, and here you mention those things. Then, if you're making improvements for next time, what are they going to be? If you need to make any changes, what they are, why we're going to make them. So that if we do the whole thing again, it just gets better and better and improves. So we can go from this unhappy face to a smiley face, everything gets the big green tick. So that next time we're doing an experiment, we know exactly what we're going to be doing. Okay. Hope that was helpful. Hope that's explained a few things about how we go about setting up an experiment, and let's try it in the lab sometime. Okay, thank you.